Let's face it, we are living in the age of AI. It feels like every single week there's a new mind-blowing breakthrough that just shatters what we thought was possible. It's just an absolutely incredible time for technology.
I mean, just think about it for a second. We have these large language models, these generative AIs, that can write beautiful poetry, create stunning art out of thin air, and even pass exams that take humans years to prepare for. These systems are incredibly powerful, they're versatile, and let's be honest, it all feels a little bit like magic. But what if all this amazing power, this magic, is built on a foundation with a critical, even dangerous flaw?
Well, that's the shocking twist we're diving into today. You see, some groundbreaking research shows that the very design that makes today's AI so good at finding patterns in the past is exactly what makes it totally incapable of navigating the future, especially when things get messy, uncertain, or when someone's actively trying to trick it. It's a massive blind spot, and we're about to put it under the microscope.
So here's our game plan. First, we're going to dissect this hidden flaw and really understand why current AI is fundamentally backward-looking. Then we'll introduce a radical new idea called QSANs and peek inside what a forward AI looks like. After that, we'll talk about the real-world benefits, things like agility and resilience. And finally, we'll zoom out and imagine what our post-AI quantum future could be.
Okay, so let's get right into this hidden flaw. Probably the best way to wrap your head around the problem with AI today is with a simple metaphor. Imagine you're trying to drive a car forward, maybe at high speed, but you're only allowed to look in the rearview mirror. You'd have a perfect, crystal clear view of where you've been, but you'd be completely blind to the road ahead. Yeah, not good. And that's exactly what this research calls backward AI. It's brilliant at finding correlations in mountains of old data. It learns that, historically, A is often followed by B. But here's the thing. In a world that's constantly changing, where the rules aren't fixed, or when a bad actor is intentionally trying to fool the system, well, just relying on old patterns is pretty much a recipe for disaster. So you have to ask why. Why is our AI built this way? To get that, we need to pop the hood and look at the core algorithms that power so much of modern machine learning. And what we find is that, under the wrong conditions, these algorithms are predictably designed to fail.
So, let's use an analogy to understand a really important algorithm called stochastic gradient descent, or SGD. Imagine a hiker lost in a super thick fog, and their goal is to find the absolute lowest point in the valley. But because of the fog, they can't see the whole landscape. All they can do is feel the slope of the ground right under their feet and take one tiny step in whatever direction feels steepest downhill. They just do that over and over and over, hoping that eventually they'll end up at the bottom. But what if they step into a little ditch instead of the main valley? They're stuck. What if the ground itself is shifting under them, like a mild earthquake? Their steps would just become chaotic.
This is exactly where our hiker analogy slams into reality. This table shows what happens when things get uncertain. For instance, that dynamic uncertainty, that's our shifting valley floor. The algorithm gets stuck in these non-stationary oscillations, which is just a fancy way of saying our hiker just jitters back and forth, completely lost. Then you have adversarial uncertainty. That's like a rival hiker kicking dirt to create fake slopes just to trick them. And look at those high agreement rates among different AI agents. This isn't some rare bug. These are fundamental, well-known weaknesses baked right into the system.
And this isn't just theoretical stuff. No way. The research shows that when an AI is under an adversarial attack, when someone is actively trying to fool it, these models can see their accuracy absolutely plummet by as much as 45%. I mean, think about that. That's the difference between a self-driving car correctly seeing a stop sign and not. It's a massive critical point of failure.
Okay, so now that we've seen just how deep this problem really goes, it's pretty clear we don't just need a software update. We need a whole new way of thinking. We need a complete paradigm shift. It is time to stop looking in the rearview mirror. It's time to introduce forward AI.
And the proposed solution, laid out in a series of really important papers by Dr. Yogesh Malhotra, is called Quantum Augmented Self-Adaptive Networks, or QASNs for short. Now listen, this isn't just some small upgrade. It's a completely new architecture, so advanced that even other AIs have analyzed it and concluded that it's, and I'm quoting here, decades ahead of our current technology.
So what's the big difference here? Let's just break it down. Backward AI is based on correlation. It just sees that two things tend to happen together. But forward AI is based on causation. It's about understanding why one thing causes another. Backward AI just rehashes the past. Forward AI can actually forge new futures. And maybe most importantly, where backward AI is brittle and fragile, forward AI is built from the ground up to be resilient and adaptive.
So that all sounds great, right? But how does this forward AI actually work? Well, the Q-Cassand's architecture is built on 3 truly revolutionary pillars.
So here they are. You have augmented human-machine quantum computing, human-centered, meaning-aware AI, and self-adaptive complex systems. Now, each one of these is a breakthrough on its own, but when you put them together, they create something that's totally new.
So, the first pillar, quantum computing, basically gives our foggy hiker a super-powered drone. Instead of taking one blind step at a time, it uses these wild quantum principles, like superposition, to see the entire landscape of possible futures, all at once. It can explore countless paths at the same time to find the actual best solution, not just the closest little ditch.
The second pillar makes sure there's a wise, human guide steering that drone. It puts human values, context, and our intuition right at the heart of the system. This isn't about AI replacing human intelligence, not at all. It's about creating a true partnership, where the AI does the heavy lifting with the massive computations, and the human provides the meaning, the judgment, and the common sense that, frankly, machines just don't have.
And the third pillar, well, it basically makes this system alive. It's designed as a complex, adaptive system, which means it's constantly learning and evolving in real time as it gets new information. If it sees a new threat or a sudden change in its world, it doesn't just crash or freeze. It adapts. It reconfigures itself. It overcomes the challenge, a lot like a biological organism would.
Okay, so let's talk about the bottom line. What's the real-world payoff? How does this completely new approach translate into actual tangible advantages?
Well, the hard data from the simulations it's pretty striking. QASNs aren't just a little bit better. We're talking about a whole different league. We're seeing a 3-time speed up in solving problems because of that quantum parallelism. We're seeing a 30% boost in resilience against attacks, and a whopping 40% improvement in performance in those chaotic dynamic environments we talked about earlier.
And this huge performance advantage lets QSANs solve what you could call the core AI trilemma. You see, with backward AI, you're always forced to choose. You can have a system that's fast, or one that's robust, or one that's efficient, but it's really hard to get all 3. QSANs deliver on all fronts at the same time. You get the agility to adapt on the fly, the resilience to stand up to attacks, and the sustainability of being way more computationally efficient.
So what does this all add up to? What's the big picture? You know, this isn't just about building a better AI. It's about a profoundly different vision for the future of intelligence itself, a future that finally moves us beyond just rehashing the past.
The ultimate goal here is to make a huge shift. We need to move away from AI that just spits out answers based on what it's already seen in its training data and move toward an AI that acts as a true partner in discovery. An AI that doesn't just process information, but one that actually augments our own human creativity and our intuition, helping us ask better questions and make those imaginative leaps that are required for real innovation.
You know, this whole forward-looking idea is just perfectly captured by one of the greatest minds in history. Albert Einstein famously said this. He knew that knowledge is limited to what we already know. It's finite. But imagination is what allows us to see what could be. It is the engine of all progress.
And that, right there, leaves us with one last really powerful question to think about. For all their flaws, today's AI systems have an unbelievable amount of knowledge. They're like these giant libraries of our entire past. So, what happens when we use this new paradigm to finally stop looking backward in the rearview mirror? What happens when we give these systems the tools to look forward, to create, to discover, and maybe even to imagine?